Now, how about drums? An instrument everybody loves.
Yo, 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 good morning or good evening. So, today is also going to be a little bit of a shorter stream, but hopefully we'll make some progress on the Fluid Solver and Stronkable, by the way. Thank you so much for the follow, appreciate it. So the idea is to implement a very simple algorithm based on somewhat of a flood fill algorithm. And good morning indeed. And the values we're going to work with are given a pixel. Let's say that we work with pixels. We're going to work with the height at that pixel and the amount we want to fill it. Like, I really want to get this. I would feel more secure if we could properly get this algorithm on paper before we continue implementing it. And working with texture, like we opted for yesterday, instead of custom data types, is going to complicate it somewhat. We could also introduce, like initially we could introduce a temporary data structure. For nodes we have already visited, basically. So the idea is something like this. Let's see if I can draw this. Good morning, Desai. I'm just trying to make this make sense for me. Total sense. So the idea is basically, if we start at this pixel, we add water amount. I don't know, A. From water amount we calculate total water amount by doing A plus H. And this is at P, but it's going to be a mess to write. And P is the position. So then, like, A here is the amount of water, H here is the height at this pixel. So we add the amount of water and height together, and then we get a total height of that node. So height plus water, that's the total height. It's this total height we want to propagate through the full texture. So from this node then, we're probably gonna go in all directions. So we're gonna move in 8 different directions. And also, when we have already visited this node, like when we have propagated out from this node, we want to mark this node. That is the question. Yeah, when we're working with amounts, like if this was just a binary flood fill, it would be so much easier. But if we're working with amounts, like each position can be affected from 8 directions, and it's going to affect 8 directions. And if we do it recursively over a big area, we might get to a point where a node is visited multiple times. Best case scenario, only 8 times. But we also need to do it since, like let's say that this node has a t that, so this node has a t that is bigger than this node's t, and if we fill this node from this direction, we're going to get a less amount, but if we fill it from this direction, we're going to get a more amount. Yeah, so that's just a small little problem we need to solve. Stronkable, do you have any video or something showing the end product of this? Not what we're currently developing, but I have some videos on my YouTube where I do some other stuff, and basically what we're trying to do is we're trying to add water to this world right here, using the texture data. So it's just going to be a simple flood fill algorithm in 2 dimensions, but with some extra constraints and stuff like that. Like similar stuff has been done, but our system is introducing a couple of constraints that makes it a little bit different. So yeah, there's a few problems to solve. Like, I mean, initially we could do a very brute force approach, so we don't care how many times a node is visited, and just go from there basically. I'm from your YouTube, only can't lie, so far all your videos have been amazing. Thank you, I appreciate it. Unfortunately, I haven't released any new ones in a while, but soon. What's up, Glutex? How is the progress for creating collection of the creatures? We haven't started with the creatures just yet. The idea is to initially get the idea now is to initially get a vertical slice of the terraforming of the game, and then get that one out so people can test it and we can iterate it. So no creatures yet, and not in the next couple of months at least. So basically what we want to do is we want to calculate this value, and then we want to propagate it. And when we propagate it, so we push out in every direction from this node, and this is the value we push. The node, or the value the neighboring nodes will push, depends on this one. Let's see here. If we have this example, for instance, let's see here, total. Yeah, the next value we want to push, like we want to send onward this value, but for each node we want to recalculate the new, or that's not entirely true. Yo, 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 what's up, Ayland? I checked out your GitHub repository yesterday. Looks nice, looks nice. Well-structured README, that's always a plus. It's a little bit weird here in this problem. So let's say that we add here, we add a value of 3. So we have the height plus the amount we add, which gives us this line right here. So when we push to this node, we're gonna have to push multiple information. We're gonna have to push TP and AP. I think. Because for instance, if we push to this one, we want to add the same, but then when we push to this one, we just want to add this much. So the amount of water we want to add here is TP minus height P1, P2. And then when we go onwards here, amount is changed and TP or AP2 and TP2 is changed. It's a little bit of a mess. When I'm thinking about implementing this, I always think about how our current data structure looks as well, and that just complicates things. A tiny bit. Would it be too bad instead of pushing a value to neighboring nodes, one could, in fact that's probably what we want to do. Couldn't you pull from neighboring nodes? So we calculate some values for this node, and then we go to all the neighboring nodes and we fetch. And then we fetch from the neighboring node. And so if we jump to this node and we fetch value from this node, this fetch from this one, and then how would it be? Initially we jump to all neighboring nodes, and then for these nodes we jump to the next 3. Is there something wrong with this approach? So from a node we jump to the next node. It's similar. It's there's really no difference when it comes to implementing it if we push or pull. But the idea then being that I don't know if this will complicate stuff or if this solution is viable when we add complexity to the system. And the initial problem being that if we jump diagonally, maybe. Okay, so what about this? Given an influx of water at position, a final water amount is calculated by where then in recursive fashion. Basically what we want to do. Like what I'm a tiny bit worried about, would we get we could probably get a scenario where if we just push from one direction, we can probably get a scenario where the water from this direction is less than the water we would get from this direction. And that's something we want to avoid, definitely. Oh, I do want to try this with a simplified system first. Maybe that is the better way to do it. Something like yeah, let's jump to fluid solver. Yeah, we're gonna introduce something I removed yesterday, but I think I'm okay with that. What's up, Ameno Pro? Okay, let's do it like this for now. The game is going pretty good. Trying to implement some sort of fluid simulation right now. A very simple one. And yeah, it's tricky. So, I'm thinking about Emana Pro, when will you release that game? I have no idea. Far into the future at least. Congratulations, Emana Pro. Do we want to implement, if we just implement it as binary initially, just get the flood fill working? Maybe. Ayland, how is your field system going to work? I don't know what you mean by field. Emana Pro, I have a plan to make a game. It would be like Granny, but with dog. Do it, man. My fluid system is going to work. It's basically going to be a type of flood fill algorithm that solves it. So basically think the fill tool in Paint, but with some water mass mixed in. Alright, Emana Pro, thank you for stopping by and have a great rest of the day. I'm still not entirely sure about how we would solve like, I'm a little bit worried about revisiting nodes. But actually, it's probably as easy as just doing it binary initially. And then calculating the height. What's up, Wesley? Ooh, that is... something I haven't heard in a while. Shortest paths. Aylan, I would make my fluid system work differently than yours. Okay. How would you make yours work? So it has to be modified, but basically you can fill the whole area, but it doesn't revisit nodes. Yeah, it has to be modified. Yeah, like it's probably something very similar to this we are looking into. But like we want to visit nodes multiple times, but only once per neighbor. So this one would only visit every node once, right? That's not exactly what we want. Do we have... Yeah, like given a node, it checks its neighboring nodes and then chooses the one with the smallest distance, right? And then if one node has been chosen by another node, that node is off the unvisited set and now in the visited set, which means that no other node will visit this. That is correct, roughly, right? Okay, previously marked with a distance greater than 8, then update it. Okay, I like it. I like it. Okay. Yeah, it's something we have been... Like, we've been thinking of a system very similar to this. It would be nice to just take this algorithm and alter it to our liking. But it's more A star is based on this but modified. Okay. Like what we want to do is like it would be easy. Okay, I think I get you, Ayland. I want that will probably. Yeah, I wonder if it would be a little bit. So if you put the water in a node, say too high, then grab all nodes around it. If they are low enough, add water, grab all node around it, rinse, repeat. Yeah, that's what I'm thinking. So like we add water to this node and then we extend out. So for this node we check this node and this node and this node. When we check the neighboring nodes of this one, yeah, that's probably what we're gonna do. So we parse out like this. But I'm a little bit worried about like initially when we jump out a layer and check neighboring nodes, the only neighboring node that has a value is this one. And then when we jump to this one, like this could, in worst case scenario, depend on this one as well, or could it? We have some constraints. That is true. Does our constraints make this way simpler? Yeah, I think it's okay. I think it's okay. Yeah, like this node and this node. Are never gonna have a higher value. Yeah. But also, if you have 1 cubic meter of water and spread over 10 nodes, you want it to be 10 centimeter high after. Like, the thing is, we're gonna do this in a very simple way initially, and then see if we can add complexity to it later. So, for instance, the ever-returning example, if we add 3 cubes of water here, then we check the neighbor here. It has a height of 3, so we can't add any water to that one. Then we check the neighbor here. This one has the same height, we add the same amount of water. Then we check the neighbor here, which is this one. This one has a height of 2 more than this one, so here we just want to add 1. And then when we check this neighbor, we'll only want to add, like, then we have reduced the amount of water, so then it's just 1, 1, 1, 1, 1. And later on we can probably complicate it a bit more. Yeah, this should be pretty straightforward, I think. We just want to iterate out, and we can, given our constraints, it's just as easy as, so we have an initial node. For that one we go in every direction. For the nodes coming after, for this one, for instance, we just need to propagate in this direction. For this one we do, for diagonal nodes we do this, 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 and so on. And it, given our constraint like this, there should never be a case where we calculate the value in this node from this node, but then it turns out it can. Yeah, we always need to check every neighbor, because this node might add a value of 3 in this direction, and this node might only add a value of 1. So the value of this one should be affected by the 3 as well. So yeah, we're gonna have to check all neighbor nodes. Yeah, it's a lot of weird constraints and things to think about, and then the underlying data structure. Like, the main goal is to represent all of this with just one channel in a texture. So at most, I think we can do it with 2 floats. So if we can manage the algorithm with just 2 float values plus height, then it would be amazing. Like what I'm talking about, you could have something like, look, so let's say that I write the height values here. So we have a height value of 1. Fuck, how am I going to represent this? 1, 2, 2, 2, 2, 2, 2, 2, 2, 6, 6, 6, 6, 2, 2, 2, 2, 6, 6, 3, 3, Or actually, six, 0, 0, 0, 2, I don't know, 6, 6, 6. I don't know if this makes any sense. Like what I'm trying to show here, in possibly a bad way, is that if we add water to this one, we have a higher value around it, so the water amount here in all the 2s will be less. So when we get to this one, it will be less. But what our flood fill algorithm will actually do is, like going this approach adds less water because of this. But then we have like a wraparound, so we have a 0 here. So, fuck, am I thinking about this wrong? I might very well be. It might not be a problem after all. By the way, 7 months ago I made a particle game made in Java before I was working on a GUI system, but I abandoned the project before it was done. Why did you abandon it? It feels like, am I gonna have to write some custom debug system for this? Like, honestly, if we go this way, if we add, let's say that we add a value of 2, then we get 3 here. We only add 1 water here, 1, let's see. We add 2 here, but then we only add 1 here, 1 here, 1, 1, 1, 1. But then we add 2 here, 2 here, 2 here, and two and 1. Okay, so it should be okay. It should definitely be okay. Or will it? Two, two, two. Yeah, basically when we initially add water we calculate TP, and then for every connected node, if that node's height is less than TP, then to that node we want to add TP minus H amount of water. That's basically what we want to do in the first iteration. Very simple one. So this is the most interesting value. This one doesn't change. It changes independent of neighbors. So but no, it doesn't. Like, how could I possibly show this in this bad drawing? But what if... What if in the Z direction, which is out of the screen, we have a wraparound to this one from this one that doesn't have this one? Yeah, then we're fucked. So yeah, we need to check every possible neighbor, because we can get affected by something. Yeah, but if we opt for Dijkstra and cost is height, yeah, I appreciate it, Ayland. I appreciate it. Yeah, I need to figure out what I should do with those. could we implement this one using height as distance? So we calculate some accumulated height value for every node, and given that accumulated height node, yeah, maybe. So basically we would use this algorithm to calculate some form of height difference from starting node, but we want to add some constraints that when we go down, when we go up, like when the height is bigger than its neighbor, then we want to reduce the water amount basically, but when we go down we want to keep the same water amount. So that would mean we can I think we can fucking use this easily, I would say. Let's see. Minimal. Yeah. Yeah, I think we're gonna use this one. Initially we're gonna use this one and we're gonna calculate. We're gonna use a system where cost is height. Now I'm just thinking more about exactly how I want to implement this and if I want to add some additional... If I want to add some additional test class for it to make it easier to develop and test. So, would it work if we use height? Yeah, so it's basically going to be... Oh, fucking hell. Indeed. It's more... like... You have to understand the algorithm and then you need to convert it to your system. And that part can be tricky. I think the algorithm itself is pretty straightforward. And then when I try to apply it to the system we want to achieve, I'm trying to think about edge cases where it won't work, or edge cases that will make this approach unusable. And when I think about edge cases, I want to think like we want to figure out first make it work, fuck edge cases, but like what if we can't even make it work with our system? What if we have some constraint in our system that makes this whole algorithm not applicable? Then we will just be sitting there with a Dijkstra implementation of an algorithm we can't even use. Make it work first, then improve. Yeah, I'm just trying to figure out if we can make it work, or like what do we need to change in this algorithm to make it work with our system, like the initial step you want to do. I would make your own. Okay. But you get the idea of grabbing the nodes. Yeah, so is this approach of grabbing the nodes, is it applicable to our problem we have? Like if this algorithm doesn't revisit any nodes because of X, but what if our solution needs our algorithm to revisit nodes based on Y? Those are the problems I'm trying to figure out. Like, does it exist? Do we have a constraint that makes us need to revisit nodes in such a way that this way of checking if a node has been visited is wrong? Like, do you understand my thinking? Well, just don't mark it as visited. Yeah, now we're starting to redefine the whole algorithm. Yeah, like, when I'm thinking about these things, it's like I want to have a clear picture of how I can make it to work, and then we can improve it. So like, it's not like I'm sitting here knowing that this will work. But I do think we can use this one. It's just a matter of the value we want to calculate here. Welcome back. Like, what I'm sitting here pondering is, like, of course I want to make it work and then we can iterate upon it, but like, this is the phase of taking something in theory and implementing it practically, and like, there's a few things you need to think about. For instance, like how we're not working with length. We don't care about length, not at this stage. So it's just about, like, what do we work with instead of length? We work with height, okay, how do we work with height? Do we always, like, how do we handle if a node has a higher height and a neighboring node has a lower height? How do we want to handle that? Like initially one could think that if it has a lower height, we just add the water, but that's not what we want to do. Like in our case, I think we want to go, so if we check a node and the height is taller, we want to add, we basically want to set that, so it's this part I'm thinking of, like how do we want this part to execute in our solution. In a distance-based solution you add, right, that's pretty straightforward, but I think in our case we're going to go with a max. We're going to max between nodes. That's how we calculate our quote-unquote distance. So if we jump to a node that has a higher height, but then we're not talking about water. If we don't care about height and instead we go water amount, so we calculate water amount. That is probably what we want to do, but then this one becomes, yeah, we want to flip it. Yeah, I think we can do it. So we create a node system, we set all as unvisited, we assign a node with a start value. For the start node, in our case, I would assign it the water amount, and for all other nodes, zero. What you do is you have your first node, say its height is 2, grab all nodes around it. If higher, mark it as wall, then keep visiting all nodes, there's nothing left. And you have the all node that is water or not. Yes, that's our binary solution. So then when we extend from that, like that binary system would yield a result like this here, right? If we just do the binary system, we get water here. And we could probably start with that. Good morning, Fabic. How are you doing today? Okay, Wesley, I like the idea of that. Let's just do it binary first. And we're just gonna do it for one patch, I think. But if we just do it the binary way, like, I'm a little bit scared that we simplify it enough. I don't want to make it realistic, but like, I'm a little bit, if we jump into the binary way of doing it, we might be simplifying it a bit much. We just have to be careful to not simplify it too much. And then when you work with nodes, you usually work with the data structure that is node based. Elon, do you ever wonder why there is 60 minutes in an hour? Not that much. I wonder more about the amount of days in a month. But it's a good start to see what should be water or not. Then you have a data set when you can... Yeah, you're definitely correct. And now I'm wondering here, we're working with textures. Could we play around with the alpha channel? Could we have the alpha channel store some data for us? Like, if we have two channels in a texture, can we make those represent nodes? The days are locked by the rotation of the sun. Then August came along and wanted an own month. Same as Julius. Okay, yeah, so it's just politics. I would love that system. Like, someone talked about a month system where you have, I don't remember how many months it is, 13 months in a year. Each month is the same amount of days. Every month always starts with a Monday. Yeah. Here's the next problem, like what I'm thinking about. Like, if we would just go with straight, if we take our texture and we recreate a node system from that texture, then it's pretty straightforward. But could we possibly solve this without doing that? I think I just need to... I just want to see. I wonder if it was this one. I want to check it out. Something like this. But yeah, whatever. Um, I would really like to be able to implement this, something similar to this, without adding additional data structures. The question is if I can. Yeah, I probably can. Let's see. But like, in some way we need to. So in the straightforward algorithm implementation, you have a list of unvisited nodes. That introduces a new data structure. How would you go about having a list of unvisited pixels? You could do it index based. So you could do a data structure that is pixel node, whatever. And now, like, when we're just trying to do the first step of this algorithm, we have already introduced an additional data types, which we may or may not need eventually. So a lot more memory usage right off the bat. And then the first step would be to do and this is the sole purpose of this one, is to keep track of which nodes we have visited or not. Oh yeah, these two can be ints, but it's irrelevant. And then the first thing we would need to do is we can do and then the first thing we need to do is for terrain patch dot do we have size? Don't we have anything we can use here? Private resolution. Terrain data, we want to keep that private, I think. So we could do and then of course we need to check With height, yes. And we could probably do this. We probably want to do this as a like this, and then we do unvisited nodes I j is equal to new pixel node is y. We don't need these ones in here if we structure it like this, so that's better, but still. So we just Jesus. Neighbors are doing some remodeling, so I guess we're gonna have to mute sometimes. But okay, now we have pretty much redefined the texture as a matrix of pixel nodes, which we can then use. But I do wonder, have we complicated the algorithm now when we represent it as a matrix instead of a list? Maybe, maybe. Honestly, I'm still wondering if... Thank you for that link, by the way, Ayland. I'm still wondering if there exists a... simpler way than this approach. Like... Okay, back. Honestly, I don't think I will be able to continue today. We have some remodeling going on right underneath. So I'm just gonna have to pick this up tomorrow instead. So what's up, Smack Gods? To answer your question, not so good. Yeah, I'm gonna pick this up tomorrow. Hopefully we will get a clear picture of the problem at hand. Slowly but surely we're converging towards it. But yeah, as always, thank you so much for watching and have a great rest of the day. Peace and sorry.